The purpose of this video is to examine the results of a differential expression profile analysis. A differential expression profile, or DEP, describes the differences in gene expression for all genes between the two sample groups in the CGP. In our example, we will compare the gene expression between samples collected prior to influenza challenge to those collected 12 hours after influenza challenge. If you would like to examine the differential expression profiles of more than one CGP, OMIC also computes a gene by CGP matrix containing genes common to all CGPs included in the analysis. This is intended for more advanced analysis outside of OMIC, so for this video we will stick to performing DEP analysis for a single CGP. Click on the DEP tab. When you set up a DEP analysis, you have the option to choose your settings. The first setting that we will consider is the method for determining statistical significance for differential gene expression between the two sample groups in the CGP. The default setting is Lima. However, other methods can also be used, specifically the Mann-Whitney test and the t-test. If you are unsure about whether to change the default setting, we encourage you to consult our tutorial or discuss these options with a bioinformatics colleague. Another setting that can be changed is the method to correct for multiple comparisons. The default is Benhamini-Hochberg method. Again, if you have questions about options other than the default, you can consult our tutorial, talk with a bioinformatician, or look at the reference documents in the tutorial section. You can also change the type of expression data used for the analyses. The default is normalized geodata. Please see the tutorial for more information on the other options. I've already run a DEP analysis with the CGP that we created in an earlier video, so let's look at those results. When you examine the results of the DEP analysis, you will see the settings that were used at the top of the page. Also notice that you can share your results by generating a public access URL. Let's look at the types of results that can be generated. First, you can download a file with the DEP statistics for all the genes or probes. I've already opened this file in Excel, so let's take a look. In this file, you will see several statistics. These were generated by comparing condition 1 to condition 2, where condition 2 is the reference. Let's look back at our original CGP and confirm that condition 2 is the pre-flu challenge sample. In our analysis, if a gene is expressed at a higher level in condition 1 than condition 2, it has a positive fold change, and vice versa for genes expressed at a lower level in condition 1 than condition 2. For the default method Lima, you have several statistics, including the log fold change, the average expression across all samples, t-statistics, the p-value for differential expression, the adjusted p-value after accounting for multiple testing, and b-statistics. For our purposes, let's look at the log fold change and the adjusted p-value. The log fold change provides the logarithmic fold change in gene expression of condition 1 relative to condition 2. The more positive the number, the greater the expression of that gene in condition 1 relative to condition 2. The more negative the number, the higher the expression in condition 2 relative to condition 1. The adjusted p-value is used to determine which genes have statistically significant differences in gene expression. An adjusted p-value of 0.05 is the default setting. A list of statistically significant differentially expressed genes is available for download. Also on the results page, one can find the list of statistically significant upregulated or downregulated genes or probes. These can be used for further analyses using tools such as gene set enrichment analysis. Please refer to the tutorial for more details. You can also view the heat map by clicking on the link. This shows the top 100 differentially expressed genes or probes between condition 1 and condition 2. Note that the samples, the columns, are grouped by condition 1 or condition 2, while the genes are clustered based on hierarchical clustering. The expressions shown are the raw normalized values. Finally, you can download GCT or CLS files, which allow you to examine and analyze data in gene pattern as another analysis tool.